So there are a number of different ways to actually measure concentration, but the one that we're going to be using in this class is molarity.
So molarity is instead of volume or mass, it's the moles of your solute divided by liters of your solution. Okay? The units for molarity are capital M, okay? And that's pronounced molar. So if I have a 10 molar solution, that's describing the molarity. Okay? So for this problem, it says calculate the molarity of a solution that has 0.127 moles of sucrose in 655 mils of solution. Okay? So here I already have my moles of solute. In a lot of problems you'll be asked, calculate the molarity of a solution that has a certain number of grams of solute. So in that case, you would have to convert from grams into moles. But here I'm already in moles, which is awesome. So my molarity equals my moles, 0.127 moles, divided by, well, I need to be in liters of solution. So I'm going to take the 655 milliliters, and I'm going to convert that into liters. If you can do that in your head, awesome. If you can't, that's fine. But get used to needing to do that conversion because it's going to happen a lot. So they're 10 to the negative third liters in 1 milliliter. Okay, so I'm going to just end up dividing by 1,000 because that's what multiplying by 10 to the negative third is. So what I get for my volume is 0.655 liters. Okay, so that's what's going to go on bottom. That's my volume of my solution. Okay, and so what I get for my molarity when I do this, 0.127 divided by 0.655, I get, well, I want 3 sig figs here. I've got 3 sig figs here. So I got 0.19389. So I want to keep the 1, the 9, and the 3 is going to round up to a 4. So 0.194. And my units are molar, capital M. Make sure it's a capital M and it's molar.
So using this molarity formula, I'm going to show you how to make solutions using 2 different procedures. And the 2 different procedures depend on how the substance is given to you in the first place. So whether it starts out as a solid or if it starts out as a concentrated solution. So what I'm going to do is I'm going to first show you the math that's required and then generically describe the process of making the solution. But then I'm going to get into the specific tools that you have to use and get into more detail about how to make the solution. So the first type of creating a solution is if what I'm starting with is a solid. If what I'm starting with is a solid, you're going to need to use the formula molarity equals moles over liters of solution. Okay, so let's look at this example problem to really understand what's going on. So it says what mass of glucose is needed to make 105 mils of a 1.02 molar glucose solution. And so I know I need to use this formula because I need to actually measure out the mass of glucose because it is given to me as a solid. Okay, so I know the molarity is 1.02, and I know that the volume that I want is 105 mils. Now keep in mind for your molarity formula, it needs to be in liters. So I need to move my decimal place 3 places to the left in order to convert it from milliliters into liters. So it's going to be 0.105 liters. Okay? And I'm solving for the number of moles, and so I'm going to multiply 1.02 by 0.105, and I get 0.107 moles. Now, it would be awesome if I could finish and be done with it there, but keep in mind, mole is simply your central unit. You cannot actually measure moles in the lab. And so instead, what I have to do is I have to convert moles now into something I can measure in the lab, which in this case is going to be mass. So I'm going to convert moles into mass, which the unit for that would be grams. And so the way I do that is I start with 0.107 moles. I'm going to get out of moles, get into grams. And so if you notice that's grams per mole, I need to use my molar mass. So I need to use my molar mass of glucose, which is 180.16. Keep in mind the way that I determined that is I took the average atomic mass of each of the elements. So for example, carbon is 12.01, multiplied that by 6, added to that the average atomic mass of hydrogen, which is 1.008, multiplied that by 12, and then added to that the average atomic mass of oxygen, which is 15.999, and multiplied that by 6. And that's how I got 180.16. So there are 180.16 grams for every 1 mole, because remember the units for molar mass are grams per mole. So I'm going to multiply 0.107 moles by 180.16, and what I get for my answer is 19.2 grams. So that's all this question asked for, and I could leave it at that, but I wanted to briefly explain how to make this solution. So what I would do is I would measure out 19.2 grams of glucose using an electric scale. Okay, that's how you measure mass in the lab. Then you're going to pour it into a container, and we'll talk about which container in a minute. And then we will fill that container until we get a final volume of solution of 105 mils. Now keep in mind, I'm not saying add 105 mils of water, because you actually won't end up with exactly 105 mils of solution. Instead, you simply need to add enough water to get a final solution volume of 105 mils. Okay, so this is the math that's needed in order to determine what mass of solid you would need to add with water to get a solution of a specific concentration. What if instead the solution that I'm given is a concentrated solution and I need to dilute it? Okay, well, if that is the case, then I need to use my formula M1V1 equals M2V2. Okay, M1 is your molarity, so your concentration. V is your volume. Okay, so really quickly to explain this process, I don't know if you've ever used orange juice from concentrate, but basically what we're doing is we are first adding our concentrated solution, which we call our stock solution, and then we're going to add enough water to get a solution of a concentration that we desire. So basically you're taking concentrated solution and you're diluting it out with water. Okay, so let's look at the math that's required by using an example. It says, what volume of 5.5 molar stock potassium chloride solution is needed to make 2.5 liters of a 0.100 molar KCl solution? Okay, so I'm basically trying to figure out what volume of concentrated solution I need. Okay, so if I'm solving this problem, M1V1 equals M2V2, the 2.5 liters is going to go on the same side as the 0.100 molar, because that's the volume with the concentration I want. So those need to stay together. So if you want to plug in those two values for your M1 and V1, you can do that. Or if you want to plug in those two values for your M2 and your V2, you can. They just need to be together. So notice here that the 0.100 molar goes with the 2.5, and then the 5.5 molar goes with what I'm solving for, my volume. And so the volume I get is 0.045 liters. Okay? So if I don't specify what units I want, you can leave it as that. However, in the lab, when we're measuring the volume of a solution, we tend to measure in milliliters. So I'm going to move my decimal place 3 places to the right. And so the volume that I need of my stock solution, my concentrated solution, is going to be 45 mils. So I'm going to very briefly explain the procedure, and then we'll get into which tools you should be using. So I'm going to add 45 mils of stock solution into a container. Okay? And how to measure the 45 mils and into what container we're going to talk about in just a second when we look at the different tools that we have in the lab. Then, so that's that first step of showing the concentrated orange juice being poured in, measuring out and pouring in the 45 mils of stock solution. Then I'm going to add enough water until I get the final volume that I want, which is, in this case, 2.5 liters. Okay, so keep in mind you're not adding 2.5 liters of water, you're simply adding enough water to get a final volume of 2.5 liters.
So you guys just learned how to create solutions. So if you start with a solid, you guys learned that you have to determine the mass of the solid that you need, add it to a container, and then add enough water to get your final volume, the final volume of your solution. If you have a concentrated solution instead, what you have to do is use your M1V1 equals M2V2 formula, determine the volume of your concentrated solution, we also call that your stock solution, add that to a new container, and then add enough water to get the final volume that you're looking for. Now, we've been saying container, container, container over and over again. Now we're going to actually look at what the tools are that we're going to use to create these solutions. So when we're measuring volume, the absolute best tool that we have for measuring volume in the lab is a volumetric flask. Unfortunately, a volumetric flask can only measure one specific volume. So we have a 25 mil, 50, 100, 250, 500, 1000, and even we don't right now have in the lab, but sometimes we have a 2,500 mil volumetric flask. So if you're creating a solution that has those exact volumes, so if I want to create exactly 25 mils of a solution or exactly 1,000 mils, that is the best tool to use because it only measures one specific exact volume. If you need to measure a volume that is different from one of those volumes, then the best tool for you to use is a burette. Now remember, we used a burette when we were working with titrations. Now the burette can maximum hold 50 milliliters. So if you need to measure a volume that's greater than 50 milliliters, then you're not going to be able to use a burette. But if you need to measure a volume that's less than 50 milliliters, let's say for example 35, your burette is your best option since you cannot use the volumetric flask because I don't have a 35 ml volumetric flask. If I need to measure a volume that is greater than 50, the best tool for me to use is a graduated cylinder. Now, I have graduated cylinders of sizes 10, 50, 150, and 500 milliliters. Okay, so those three are tools that I can use for measuring volumes. What about measuring mass? Well, if I'm measuring the mass, meaning measuring a solid, I'm going to be using an electric scale. So let's go back to those two example problems and figure out what tools I would need to use. So the first example problem, if you'll go back, was about creating the 1.02 molar glucose solution, 105 mils of that. Okay? So keep in mind that the glucose is a solid, and so what I'm going to have to do is I'm going to have to use an electric scale. So we had determined that you needed 19.3 grams of your solid. So I need to weigh the 19.3 grams of glucose using my electric scale. Some other tools that you could use would be like a spatula in order to scoop it up. You'd use a weigh boat in order to put the glucose onto the electric scale. But the main point is in determining the mass that you have, you need an electric scale. Then I'm going to have to add it to a container. And that container needs to be able to measure up to 105 milliliters. So if you look back at the tools that you have, my volumetric flask doesn't work because I don't have a volume for 105 mils. Burette doesn't work because 105 mils is greater than 50 mils. So I'm going to have to use a graduated cylinder. Now, I have a 10, 50, 150, and 500 mil graduated cylinder. I cannot use the 10 or the 50 because those volumes are too small. I need 105 mils. So I would use the next size up, which would be 150 mil. So after weighing it using the electric scale, I would then add my solid to the 150 mil graduated cylinder. Once I've added the solid to the 150 ml graduated cylinder, I would add enough water to get a final volume of 105 mils. Okay, so that's how you create a solution from a solid. What about if I'm just diluting a solution? So here, we went through the math of this, but I have a 5.5 molar stock solution. I want to create a 2.5 liter solution that has a concentration of 0.100 molar. So after using M1V1 equals M2V2, we determined that I want 45 mils of my stock solution. So how do I measure 45 mils? Well, if we go back, keep in mind I don't have a 45 mil volumetric flask, but I do have a burette because the burette measures up to 50 mils. So I'm going to measure the 45 milliliters using a burette. Then I need to add that to a container because I'm going to have to get a final volume of 2.5 liters. Well, do I have a volumetric flask that can measure 2.5 liters? I do. I have the 2500 mil volumetric flask. And so I'm going to take the 45 mils from the burette and I'm going to pour it into the volumetric flask. Okay. Then I'm going to add enough water to get a final volume of 2.5 liters. Okay. Keep in mind we don't measure the exact amount of water, and the reason why is it isn't actually additive. When you take a solution and you dilute it, the particles themselves can actually cause the volume to decrease based on how they interact with water. And so you're not going to ever add exactly the amount. Like for example, here, I would never take 2500 and subtract 45 from that to get the volume of water. It's not going to be exactly that. So instead, I simply say I'm going to add enough water to get the final volume that I want, which is 2.5 liters.